Is that clear? Question is clear for you? Please give me a yes or no. Just give me a yes or no. Okay, I'll give you the answer. The answer is simply yes or no, depending on the context. Okay. See, in this case, our input has only 5 numbers. So you just plot only those inputs and corresponding outputs. Okay. In this case, our input has only 5 discrete values in the input. So you just simply plot only those points. But if your input is the complete set of real numbers, say for example, okay, if your input is complete set of real numbers, you can get a continuous graph. You can get a continuous graph. Okay. So when you join this dot, it is understood that the function also includes the points in between. So instead of just these discrete points, if you are simply joining the graph, it means that every point in between these points are also included in the function. But in this case, in this specific case, it's not the case. In this specific case, we have just 5 inputs and correspondingly there are 5 outputs. So in this case, we cannot join the graph. Okay. In this case, we cannot join the graph. So depending on the situation, depending on the context, a context is nothing but the domain, the set of all inputs. Depending on the input you have, you can choose to join the graph or you can simply represent them as just discrete points on the graph. Okay. So we are discussing the ways to represent a graph. The first method is using a mapping diagram where you show the mapping between input and output. The second way is you just represent it as ordered pairs, the pairs, and they are put inside a set. Okay. And third one is you just represent it as an input output table where the first column will represent the inputs and the second column will represent the corresponding outputs. And the fourth method is you just represent them graphically, right? And the next method is the most important one. The next method is using the function rule. Using function rule. Okay. So in this case, what we are going to do is the relationship between the input and output is represented using a function rule. And that is going to be an algebraic expression. Okay. For example, in this case, just by looking at the table, you know that the output is nothing but the square of the input. The output is nothing but the square of the input. Do you understand from this table? Do you get that from this table? The output is nothing but the square of the input. Yes or no? Hello. Hello. Yeah. So what I'm going to do is I'm going to write y is equal to x squared. What does it mean? What does it mean? For x is the general symbol we use to represent the input and y is the general symbol we use to represent output. So this function rule simply says that your output is the square of the input. Okay. And you have to mention that your x value takes values from 1 to 5. Okay, 1 to 5. You have to just mention that. Okay. So instead of y, it is often a good notation to write it as f of x is equal to x squared. Okay. This is read as f of x, not f times x. Okay, it's not f times x. This simply means that f of x is x squared. So corresponding to an input x, your output is the square of the number x. So corresponding to the number 1, the output is f of 1 is 1 squared, which is 1. Corresponding to the input 2, the output is 2 squared, which is 4. Corresponding to the number 3, the output is 3 squared, which is 9. Corresponding to the number 4, it is 4 squared, which is 16. Corresponding to the number 5, it is 5 squared, which is 25. Clear? Yes. So these are the 5 different ways to represent a function, and this is what we will encounter the most often. Okay, f of x is equal to x squared. It means that the output value corresponding to x is represented as f of x. F of x. Okay, f is the name of the function. F of x will give the input value. So if you give an input x to this function f, if you give an input x to the function, it will throw up f of x as the output. Okay, so your output y is often represented as f of x. So if you give 3 to this machine, this function, this is going to give me your y value, that is going to be f of 3, that is going to be 3 squared, which is 9. Yes, if your x value is 3, your y value will be 9. So that is the idea here. Okay. So we are not going to discuss about different functions here. Our idea is to focus on linear functions. So let's see what are linear functions. We are going to talk about linear functions only. Okay. And when we are talking about functions, unless otherwise specified, the domain will be the set of all real numbers. Okay, the domain is going to be the set of all real numbers unless otherwise specified. Okay, see, for example, when we are talking about linear functions, what is a linear function? A linear function is nothing but a polynomial in x, with degree 1. Basically, if you give the variable x as the input to the machine, you are going to get a polynomial in x with the degree 1. Basically, that is what we call a linear expression. If you give input as x, the output will be a linear expression x. For example, 2x plus 3. 2x plus 3. Y is equal to 2x plus 3. Y is equal to 2x plus 3. This is a linear function. Why? Because you are assigning something to y, and that something comes out as a linear expression x. Okay. See, you have to understand the difference between an expression, a function, and an equation. 2x plus 3, if you simply take it, this is what we call a linear expression. Okay. If we have 2x plus 3 is equal to 0, this is what we call a linear equation. Okay. Now, if somebody tells you y is equal to 2x plus 3, this is what we call a linear function. So in this case, what we are doing is we are mapping your x values to y values, and the y values are related with x values in such a way that it is a linear function of x. It is a linear function of x. Okay, it is a linear function of x, which means your y is going to be a linear expression in x. Okay, as an example is 2x plus 3. And you have to remember that unless otherwise specified, the domain is going to be, if I simply say that a linear expression is y is equal to 2x plus 3, if I simply say that a linear function is 2x plus 3, it is understood that the domain is set of all real numbers. The domain is all real numbers. Domain is all real numbers. Unless otherwise specified, it is understood that the domain is all set of all real numbers. Okay. So you know that a linear expression can always be of the form mx plus c. A linear expression will always be of the form mx plus c, right? A linear expression will always be of the form mx plus 3, mx plus c. Okay. M and c are constants. M and c are constants. And in a linear function m is usually called the slope. And this is what we usually call the intercept. Sometimes it's called the intercept, or sometimes we call it the y-intercept. Y-intercept. So my question is very simple. When you're given a function in this form, when y is given in this form, okay, say for example, as function rule, we have a function f of x is equal to 2x plus 3. How do we know that it's a linear function? You just check the expression here. If this is a linear expression or a linear polynomial, we say this is a linear function. Simple. So just by looking at the expression, just by looking at the function rule, how can you tell it is a linear function? If it is a linear function, we have a linear expression on the RHS. That's all. Simple. So by looking at the function rule, how can you tell it is a linear function? You have a linear expression. That's all. Yes. Now, if the expression is in this form, y is equal to mx plus c. So this is an equation representing the relationship between x and y. By looking at this, how can you say that this is a linear function? Simple. Again, say if I have y is equal to 2x plus 3, your output is written as a linear expression in x. So again, this is a linear function. This is again a linear function. And sometimes instead of y is equal to 2x plus 3, it can be written in this form as well. 2x minus y plus 3 is equal to 0. So this is what we call a linear equation in two variables x and y. This is actually a linear equation in two variables x and y. But it is understood that this actually represents the input-output relationship y is equal to 2x plus 3. So the first method is by looking at the function rule. You can say that a function is linear. Second method is if you have an equation that represents the relationship between the input-output variables. That way also you can say that it is a linear function. Okay. So my question is this a linear function? 2x plus 3y plus 6 is equal to 0. Does this represent a linear function? 2x plus 3y plus 6 is equal to 0. Does this represent a linear function? Please let me know. Does this represent a linear function? Does this represent a linear function? Can you please let me know? Does this represent a linear function? Yes. Why? Because this is a linear equation in both x and y. Why do we call it a linear equation? You look at the power of x, it is 1. Look at the power of y, it is 1. The maximum power of x and y is 1. Okay, this is a linear equation in x and y. A linear equation in x and y can be converted to a input-output relationship. How? We have 3y is equal to minus 2x minus 6. You divide it with 3. We have minus 2 by 3 times x minus 2. See this? So this actually represents the function f of x is equal to minus 2 by 3x minus 2. So that actually represents the function f of x is equal to minus 2 by 3 times x minus 2. Right? So this is what we call a linear function. So the second way is by looking at the equation that represents the input and output, the relationship between input and output. You can say that it's a linear function. Is this a linear function? 2xy plus 5y is equal to 7. Will this represent a linear function? Will this represent a linear function? Will this represent a linear function? Please let me know. Everyone. Will this represent a linear function? Will this represent a linear function? No. Why? Because this is not a linear term. This is a quadratic term because here x is raised to 1, y is raised to 1, and here these are multiplied. So power, the degree of that term xy is 2, actually 2. Okay, this is a quadratic term. 2xy is a quadratic. Okay, so it's not a linear function, Or you can try to find the input-output relationship. So you take y outside, so this becomes 2x plus 5 is equal to 7. Your y comes out as 7 over 2x plus 5. So your f of x is 7 over 2x plus 5. So from this case also you can say that this is not a linear function. This is not a linear function. Cool. So first way is just by looking at the function rule. Second way is by looking at the equation that gives the relationship between the input x and output y. If that is a linear equation, both x and y, that is going to be a linear function. Yes. And third way is if you have some ordered pairs given. If you have some ordered pairs given, sum of the ordered pairs on the function is given. Okay. Then how can you say that it is a linear function? Let's see that. So next method is by using ordered pairs. Okay, I'll give you an example. See, an f is given as 1, 5, 0, 2, 7, 3, 9, 4, 11. We have 1, 5, 2, 7, 3, 9, 4, 11. Some ordered pairs on the function is given. Some ordered pairs, okay? Some ordered pairs, not every ordered pair is given. Some ordered pair is given. Now, how can you tell that this represents a linear function by just looking at these ordered pairs? Or instead of ordered pairs, you have a table. See, both are same. Instead of representing it as ordered pairs or input-output table. So we have x here, y here. 1, 5, 2, 7, 3, 9, 4, 11. If I have an input-output table, how can you tell that? How can you tell that this represents a linear function? Any idea? Any idea? Any idea? Does this, first of all, my question is, does this represent a linear function? Does this represent a linear function? Does this represent a linear function? Tell me, tell me, tell me. Yes, Anjali is saying yes. What about others? Please, please. I would like to get an answer from everyone. Anjali is saying yes. I would like to get an answer from everyone. Yes. Can you tell me why? See, this idea is very important, okay? Because we are going to see word problems and real life problems based on this idea. Okay, we are going to see soon such questions. So it is very important that you understand the logic behind this. So what is the logic here? Why do you say that this is a linear function? Why do you say that this is a linear function? Yeah, you are thinking in terms of slope. Yeah, that is true. Others, what is the interpretation here? Okay, listen carefully. Please listen carefully. This is the intuition here. Yeah, do not think of, we don't have to go to lines and slopes for the time being. Just look at the changes in x. Look at the changes in x. Okay, look at the changes in x. What are the change in x? Here it is 1, 1, 1. And corresponding to constant changes in x, do we have constant changes in y? So we have 2. The change here is 2. Change here is 2. The change here is 2. Yeah. See, if you take constant changes in x, the changes in y should be also constant. I mean, this is the same idea of slope. The slope should be constant. I mean, slope, I have not come to the slope idea yet. I'm giving a simpler idea now. Then we'll go to slope, okay? See, we are building things one by one. So I'm giving a simpler idea now. You look at the table. If you have constant changes in x and corresponding to constant changes in x, if we have constant changes in y, then we say it's a linear function. Yeah. And this is the same thing as you have described, what Prisha and Anjali has told. It's the same thing. You take change in x, delta x, you take change in y. This ratio is always, sorry, it should be the other way. Delta y over delta x is always 2. If you take any pair of points, delta y over delta x is going to be the same. But it was not the case in this function. Remember, if we had this function, what was the case? See, what was the case here? Please have a look and let me know. The changes are 1, 1, 1, 1. But corresponding changes in y are 3, 5, 7, and 9. See this? For a constant change in x, the changes in y are not the same. Now you understand, right? So is this a linear function? Does this represent a linear function? Does this represent a linear function? No. No. We just said no. This does not represent a linear function because the changes are 1, 1, 1, 1, 1. The changes in y are 3, 5, 7, 9. They are not same. It should be the same for it to be a linear function. See, here we have seen that. Here we have seen that if you take 1, 1, 1 as the changes in x, corresponding changes in y are all 2, 2, 2. Right? But here, what was the case? What was the case here? Does that make sense? Prisha, is that clear now? I mean, I think you just got confused. That's all. Others. Yes. So you know how to figure out that a function is linear from its function rule, from an equation that represents the input-output relationship, from the table. Okay. Now, from the graph of the function, how can you figure out that a function is linear? From the graph of the function, how can you figure out that a function is linear? From the graph of a function, how can you figure out that function is linear? From the graph of a function, how can you figure out that a function is linear? By looking at the shape of the graph. And what should be the shape of the graph? It will be a straight line, right? It will be a straight line. So if we have a straight line, so it means that it is a linear function. If we have a straight line, that means we have a linear function. Is that clear? So the next method is by looking at the graph. Looking at the graph. For example, if I have, say, y is equal to 2x plus 3. Y is equal to 2x plus 3. This is a straight line, right? And we just saw some of the points on the graph. 1, 5, 2, 7, 3, 9, 4, 11. These are all points on this graph. See, A is equal to 1, 5. We have 2, 7. We have 3, 9. And we have 4, 11. See? If you take the graph of a linear function, it's going to be a straight line. Now it makes sense, right? It also makes sense why we have for different changes in x, I mean for the same change in x, why we have constant changes in y. From this graph, it's clear. Is that okay? Now see this in the graph. I'm sorry. This changes here is 1. Correspondingly, change here is 2. The change here is 1. Correspondingly, change here is 2. The change here is 1. The change here is 2. Okay. So usually this change in x is what we call run. And this is what we call rise. Okay. Change in y, our change in x is what we call slow. We are coming to that. Okay. We are coming to that soon. Right. Rise over run is what we call slope of a line. For a straight line, the slope will be same everywhere. Irrespective of the points you choose, it will be same everywhere. Okay. But it will not be the case for other curves. It will not be the same for other curves. For example, if we have something of the form y is equal to x squared, if I have something of the form y is equal to x squared, and suppose we take some points, suppose we take some points on the graph, say take a point here, take a point here, take another point here. See this example. Now, when going from 1 to 2, here in this case, this is 1 and it is 3 here. But when going from B to C, if this is 1, this is 5. See this? They're different, right? So this is not a linear function and this is not a straight line. Clear? Okay. Now, if this basic idea is clear, I mean, there will be a lot of questions coming from this topic, okay? In SAT, there will be a lot of questions coming from this topic of linear functions and the real world applications of linear functions and their graphs. Okay. So it is very important that you have a very good idea about linear functions. Okay. There are a lot of situations where you see linear functions. Okay. For example, I'll give you an example. One example is when you have a proportional relationship. For example, say you can buy one chocolate for $2. I can buy 2 chocolates for $4. Similarly, 3 chocolates for $6. And this represents a relationship. Okay. If you want X number of chocolates, the money that you need to spend will be 2 times X. Y is equal to 2 times X. Okay. Somebody tells you that, see, I need to get 75 chocolates. 75 chocolates. So how will you work out? Simply say that the amount of money that will be required to get 75 chocolates will be 75 times 2. That will be $150. Got it? So this is the simplest case of linear function. Okay. There are a lot of situations in real life that can be modeled using a linear function. So it's very important. Okay. Linear function is something that we will encounter on a day-to-day basis. Okay. So you'll see a lot of real-world problems in our problem sheets. Okay. I'll give you some simple examples, and at the end of the class, I'll also share a problem sheet for the next week. Okay. For the next week, I'll share a problem sheet based on what we discuss. The simple ideas. Okay. A very simple idea of linear functions. Of course, there are other functions like exponential functions, quadratic functions. You will, in higher classes, you will see trigonometric functions. Okay. But for the time being, we are going to see the simplest of the functions. Simplest of the functions are what we call linear functions. And you have to also understand that the constant function, suppose instead of y is equal to mx plus c, if we have just y is equal to c, this is what we call a constant function. Constant functions are also considered as a special case of a linear function. Okay. Constant functions are also considered as a special case of a linear function. Okay. So tell me which of this following, I'm going to give you some examples. Tell me which of them will represent a linear function. I have 8x plus 5. I have 8x. Sorry. Y is equal to 8x plus 5. Y is equal to 8x. Y is equal to 8 by x. Y is equal to 8 minus x. Y is equal to 8. Y is equal to x. X is equal to 8 y. X is equal to 8 minus y. X is equal to 8y plus 5. X is equal to 8. See, I have 10 expressions given here. Tell me which of these will represent a linear function. Which of these will represent a linear function? Which of these will represent a linear function? Or rather, which of them will not represent linear functions? Y is equal to 8x plus 5, y is equal to 8x, y is equal to 8 over x, y is equal to 8 minus x, y is equal to 8, y is equal to x is equal to 8y, x is equal to 8 minus y, x is equal to 8y plus 5, x is equal to 8. Which of them will represent a linear function? Can you just note down this expression first? Can you just please note down this? Please note down these expressions first. Because it's almost time. We are running out of time. So in case we are not able to discuss the entire thing, we can do it in the next class. Please note down these expressions. And tell me which of these will represent a linear function. Which of these equations will represent a linear function? Tell me all you have to list down all of them. Okay. It's not just one represents a linear function. Did you note down all these expressions? 10 of them? 10 of them? First one. What about first one? Does that represent a linear function? First one. Does that represent a linear function? First one. Please give me an answer. First one. Does that represent a linear function? Yes or no? First one. Does that represent a linear function? Okay, I'm waiting for an answer. Does that represent a linear function? The first one? Yes. Yes. This represents a linear function. The second one? Second one, does that represent a linear function? Yes. Yes, right? You can have a constant, you may not have a constant, then that's fine. This represents a linear function. Y is equal to 8 over x. Does that represent a linear function? Y is equal to 8 over x. Does that represent a linear function? Y is equal to 8 over x. No, this does not represent a linear function. Y is equal to 8 minus x. Okay. Does that represent a linear function? Yes. Y is equal to 8. Does that represent a linear function? Y is equal to 8. I just told you that y is equal to 8 is nothing but a constant function. Y is always a constant. Y is always 8. Y is always 8. So this is a constant function. In fact, this is considered as a special case of a linear function. Because, even if you take y is equal to 8 and plot the graph, if you plot y is equal to 8, what are you going to get? You are going to get a straight line. See, y is equal to 8 will give you a straight line. So even though that's a constant function, we are going to consider it as a special case of a linear function. All right. So this is a linear function. Y is equal to x. Is that a linear function? Yes, that is a linear function. Pretty much. Y is equal to x is a linear function. What about x is equal to 8y? X is equal to 8y. You look at y. Y comes out as x over 8. Is that a linear function? X over 8. Y is equal to x over 8. Yes, it is a linear function, right? Y is equal to x over 8. X is multiplied with the number 1 by 8. Okay. Y is equal to x over 8. See? Y is equal to x over 8. Will represent a straight line. But y is equal to 8 over x was different. Y is equal to 8 over x was different. Okay. That represents something else. Y is equal to 8 over x represents something else. But y is equal to x over 8 is going to represent a straight line. What about this? X is equal to 8 minus y. X is equal to 8 minus y. Does that represent a linear function? Does that represent a linear function? Does that represent a linear function? Okay, anyway, I think we have run out of time. I guess we'll discuss the remaining parts, H, I, J, in the next class. And I also share a problem sheet. Please spend some time on it, okay? Because the linear functions and their applications is a very important topic as far as SAT is concerned. Okay. Also, it's very easy. You can score very well in these topics because these are very easy topics. All right. So see you in the next class. Okay. Yeah. Bye.